Linear equations in two variables. These are basically x, y lines that are inequalities instead of equalities. They could be written in standard form as ax plus by is greater than or equal to c, or you can substitute any of the inequality symbols for this greater than or equal to. Important point here, the solution is any point x, y where the statement is true. So any point that you plug in where you get a true statement is part of the solution set. And it's a large solution set in general. We graph these on the coordinate plane. Okay. So that's what we're going to do. We're going to graph the following examples. Okay. Here we have y is less than or equal to 4. So since it's a less than or equal to, your line is going to be solid. It's a y equals, so therefore it only crosses the y-axis, making it a horizontal line. So we draw a horizontal line where y is 4. And less than or equal to, that would be below it, so that's where we shade. Done. Anything in the shaded region is true. The point 0, 0. 0 is less than 4. It's true. Okay. B, x is greater than negative 1. Okay. X is the only variable in the equation, therefore it only crosses the x-axis, making it a vertical line. So this is a vertical line where x equals negative 1. Now here you have to be very careful because this is just a greater than, so therefore our line must be dotted or dashed. So draw a vertical line where x is negative 1. Now everything where x is greater than negative 1, that's going to be on that side of the line. So that's why we're going to shade. Next, two variables. Okay. Example 2. Y is greater than negative 1/2 x. Okay. We have to first graph our boundary line. Okay, the boundary line is going to be y equals negative 1/2 x. Now when we graph that, it is in slope-intercept form. It's in the y equals mx plus b form, so therefore that's nice because then we plot the y-intercept and use the slope. Well, what is the y-intercept? Where is it? There's nothing. Oh my gosh, there's nothing there. You know what that means? That means your y-intercept is 0. So you put a point at 0, 0. And then using your slope, it's negative 1/2. I always keep the negative with the rise part. You know, it's rise over run. So if it's a negative slope, then I go down 1 and over 2. So down 1 and over 2. Now, here's where it's careful. You have to be very careful because it's just a greater than. Draw your dotted line. Now we have to find a point. We have to find which side to shade. Greater than might tell me that side, so I'm going to pick a point that's on that side. One of my favorite points to pick is always 0, 0. But wait, 0, 0 is on this line, so I can't pick 0, 0. So that means I'm going to pick 1, 1. Okay, so this is going to be my test point. When I plug in 1 here and 1 here, what do I get? I get, 1 is greater than negative 1/2 times 1. Is 1 greater than negative 1/2? Oh yeah, sure. So that's the side that we shade. Okay. Next one. 3x plus 4y not equals is less than or equal to 3. In this case, I would use the intercepts to slope. I'm given the equation in standard form. My boundary line is 3x plus 4y equals 3. So I'm going to use the intercepts. X, y, 0, 0. If I plug in 0 for x, 4y equals 3. Divide by 4. Y is 3/4. Yeah, I got to estimate a little bit, but that's okay. We can do that. If y equals 3, then this one goes away, and I got 3x equals 3. Oh, x equals 1. That's nice. That's convenient. Plot those 2 points. 0, 3/4. That's going to be about here. And 1, 0. Now going back to the inequality, less than or equal to, so solid line. And my favorite test point is available this time, 0, 0. If I plug in 0 and 0, do I get a true statement? Oh, 0 plus 0, that's 0. Is 0 less than or equal to 3? Yes, it is. And that is all I have for you.